Hi everyone. In today's class, I wish to share the Python demo before we move on to the chapter 3. And as we discussed the last time, we will have this moment to do analysis on the CO2 related statistics and visualize the plots as we want. And for that, we are going to use the Anaconda, which is the version control tool for the Python. And and among the different editor for the Python, we are going to use the Jupyter Notebook, which is which enable a interactive Python execution. So when you are gonna have a presentation before many people, then this Jupyter Notebook probably more useful than any heavy or deeper Python scripting. So let me get it started. So first, please go to your iClass, and then from the iClass, you will have this announcement. So after today's demonstration, making our 4 different plots will be the assignment that is due next Tuesday. So please, after finishing the demonstration, please make the figure as we have a description. And in doing so, if you have any comment or feedback or any question or error messages, please ping me or TA, and we will be very happy to help you. So if you scroll up, in the second week, we have 2 different CSV files and then 1 Python script. So please download all 3 and now okay, let me give some moment. Okay. So under the C driver, under specific name for this folder, I just create this folder, and I'm gonna copy and paste all the downloaded files in this location, and you can actually pick any location in your local computer as you want, because you should be able to run the Python script in any location. So it's up to you. So let me unzip it, and the reason why we zip the Python script here is because iClass they prevent us to upload a raw Python script, probably due to some security issues. So that's why we had to zip it. But now we have 2 CSV files and 1 IPYNB, and then that stands for the Interactive Python Notebook. If I may briefly show you what the data file look like, if you open this one, then it will have are the name of the column. 안녕하세요. 저 지금 녹음하고 있었는데요.
아, 그래요? 아, 그럼 저 나가면 되는 건가요?
근데 지금 방금 시작한 거라 계속 보시려면 계속 보셔도 됩니다. 근데 뭐 편하신 대로.
네. 네, 감사합니다. 그럼 가만히 있겠습니다.
그래요? 그러면은 조용히 해주셔야 돼요.
네.
So from the iClass, we had 3 files, and please download it and then locate all 3 files into a specific folder that you want to work on. And if we open the second CSV file, which is here, we have a name of columns, because we have data set. In the data set, we have a different informations, and each information is labeled by different columns, such as country name, years, GDP and population, and CO2 is the total amount of CO2 emission of each country per specific year. and on the right-hand side, we have a more detailed explanation as well as their data reference. So the author for this data set, they extract this information from this source. And if you open the last one, this one is bigger, and it takes about 13 megabyte. So I just open it. So if you open the bigger CSV file, then this is how it looks like. So as we just briefly check the type of the columns, we have our different columns here, and also in each row we have country name, year, and their ISO code and their population. And in case we don't have any record for that specific year for specific country, then it's just empty cells. And it starts with the alphabetic order, so we start with Afghanistan, and it goes all the way down to the Zimbabwe, which make about 50,000 rows. So if you have to do the data analysis or the manipulation on the Excel right away, then it will take a lot of time, because first, it's just too long, and second, there's a lot of missing data which is not automatically screened by the Excels. And lastly, once you get your analysis and you have to move on to the other country, then you may have to do the other work that you did manually. So working on the Excel is really onerous, and that's why it is more recommended to start to use the Python, because Python we have the capability to manipulate and do the analysis. In the last class, I requested to download and install Anaconda. So please open the Anaconda Navigator. So once you install the Anaconda, then you will have this program, and once you open it, this may take some time, but it's okay. So once you open the Anaconda, we have a variety of different options to write our script. And out of this, in this class, we are going to specifically use this Jupyter Notebook. So now we have all these data file, all these three files, and we want to we want to open this Jupyter Notebook on this specific location. So from the Anaconda, go to the environment, and from there, you will have a base and the root, and then next to the name, it has this triangle icon, and if you click, then you can open the terminal. This may depend on which operating system that you use. In my case, I'm using the Windows, and that's why this is like a window command terminal. But if you are using the Mac or the Linux, then you may have a Linux terminal. So if I may show you a brief introduction to this terminal, basically, well, we open the folder and then get to the folder and then execute the file by clicking from the window explorer. But basically, we can do the same work using this terminal. So in this location, which is the C driver, username, and there, I can check what are the folders or files that we have in the location. And if I want, so for example, if I want to go to for example, the music folder, then I can change my directory by using the CD, capital C and capital D, which stands for the change directory, and then music. Okay. So I just move to the music, and this mark, which is same as the Korean currency mark, this indicate the backslash to separate the different folder in the directory. So we are under the C driver, user, there, and the music now. And then under the music, I probably have nothing here, so it's empty. So we wish to get to here. So go back to your folder and copy and paste your directory. And then you can simply CD and copy and paste what you just copied. And now we are in the same location. We can see it on the window explorer, and at the same time we can also check it from the terminal. Okay. I wish to have my small webcam here, which probably better, but I don't know how to. Let me stop sharing my screen and just let me reshare it. Okay, it's not working. How can I? So okay, this is okay. I'm still here. So if you type the dir, which is to check what are the files or the folder that we have here, we have 3 names, 2 data files and 1 Python script. And from here, now we have to open our Jupyter Notebook. So type Jupyter Notebook. Please note that the P in the Jupyter is Y, not the I, and that's because PY stands for the Python. So if you type the Jupyter Notebook and hit the enter, then you will probably have your browser pop up, and you can see all these data file and the script here. So I'm using the Google Chrome as my default browser, and then the Jupyter Notebook basically it's HTML-based editor program. So that's why instead of having any external program to run the Jupyter Notebook, it just execute it within any browser that you have. But that doesn't mean all these files are online. They just borrow the browser, but all the information you are working on here is gonna be saved and executed in your local machine. So there's no leakage of your data out of this Jupyter Notebook. So open the first one, demo_ghg_CO2. And from here, so this is how the Jupyter Notebook look like. First thing that I wish to let you know is, so if you click this plus icon, then you can just make a new block or cell. So sometimes people call it the block, or some people it's more openly called cells. So you can create this cell, and basically the Jupyter Notebook is a set of a series of the different cells, like this one and this one and this one and so on. And so in this cell, we can actually make either in code or markdown. There are 2 more options, but for now I'm not going to cover this. So the code is the cell where we can write a Python script. So from here we can use Python script. For example, I will just give a simple example. 102 plus 1, what is it? 103, right? So if I run it, then we can get the output. And this is basically Python scripting and execution. And also, if we switch it to the Markdown, this is simply to save the text or explanation or description of your work. So, hi, for example, this is Honggen, and from now on, we will get started. So in this case, in this cell, it will just have a simple text or description, and it won't run any Python. It will just the text. So basically, the first cell is actually Markdown, and we have the course name and explanation of what this is about. In this demo, we are going to use the packages that is called the pandas. So if you click it, it has a page for the pandas Wikipedia. And in short, this is Python library that is for the data manipulation and analysis. Any advanced statistics or machine learning or data analytics, they are partially rely on the pandas. So I can say that the pandas is one of the most crucial packages that you have to learn if you want to use the Python. So that's why we are going to use the pandas. And of course, there's more packages, but the point here, I wish to just use the pandas only to that so that we can visualize the figures that we wish to have. So there's more information about the data set. So we get the data set from here, and here we have actually this script is more for extracting all the information as the up-to-date data set, but they already run it like I don't know, like 2 months ago. So that's why instead of executing this script again so that we can get the other information in a newer version, we are just gonna use these two files that are already provided in the I-class, and that's it. So this is where we get the data. And please reach me out or TA if you have any questions. So this is basically explanation, which is under the Markdown. And from second one, now we are having the code like a Python. So first, because we are going to use the pandas, import is the keyword to import the packages, because the pandas is just too long. So we want to call it in a short, like a PD. So we are going to import the pandas in a short name PD. So after this, we are going to call the pandas using the PD. So we run it. And now we have the pandas in this Python. And the next one here, if you open this Jupyter Notebook in this location, then under this location, we have all these two CSV files. So here we are gonna read the CSV file using the PD, the pandas. So pandas.read CSV is the command to read the CSV file, and we are gonna save that information under the name our data frame. I just did it, and if I show you, I just click the plus icon so that we can have additional cells, and by default it's a code cell. So if I just type the name for this variable, our data frame, and if I hit the enter, then it shows our first 5 rows of our data set and the last 5 rows of our data set. It starts with Afghanistan and ends with Zimbabwe. And in the Excel file, we checked that it was empty or the void, but Python doesn't want any ambiguity. So instead of having just empty, which might be some useful information or not, so they specifically say that it has no information, and the none means basically we don't have any record or the information in that case. So that's why we had a lot of none, and every time we had a none, that means we don't have the GDP information of Afghanistan in 1850. And if you click the seizure icon, then you can also remove it. So now we have all the information under this name. And before we move on forward, I wish to provide you how to use the very basic function, which is print. So print is to print the output in the Python, and within the print, it takes the string. So in the first line, we are gonna print out these like this. Hi, this is print, and if we have a multiple print, then we can print out the multiple lines of the string. And by the way, the string is a series of the character, and this is one type of the variable in Python, and the other type of the variables are integer, float number, and so on. So, but now it takes the string, and to say that this is a string, we typically put the quotation mark from the beginning until the end, and then that indicated any character within this two quotation mark, like a two single quotation mark, they are string. This is another string, and so so we can have as many print as we want in a one cells. And if we want to switch the line, then we can use \n, and this backslash is located right next to the enter. So if you look into your keyboard, you can easily find the question mark and the slash, like a forward slash, but the backslash, it's in the second row, right next to enter. So you can find it. So this is backslash. Depending on different operating system, the backslash sometimes shown as this or this, like a. And then this is the forward slash or the slash. So this is backslash, and this is backslash, and this is slash. And we knew that we also use this backslash to separate a folder within the terminal, right? Okay, within the terminal. So we also use the backslash. So that's what it is. So backslash, and this means we want to change the line. So after this, it will change the line so that we had one empty line after this. And here, in case we have some other variable, and if you want to include that variable within the string, and this is how we can do. Put the f in the beginning, and this is called, by the way, called f string, and it works only after Python 3.7. If you install the Anaconda and everything last week, you will have a Python 3.11, which is the newer version than when the f string starts to use. So you should have this functionality in your Python for sure. So put the f in the beginning, and the quotation mark, and the quotation mark, and then within the quotation mark, whenever you want to call that variable, put this curly mark, curly bracket. The curly bracket is that looks like this one, and then the another one, this one. The open curly bracket and the close curly bracket, and within that curly bracket, you can put the name of the variable. So I want to print out the 3 here, and also depending on how you want to use this, you can also do this. So 4 has a 4 and 3 has a 3. So I just summed, and it will give us the 7. So if I execute it, then we will have already output here, and here is the where we have this, and then we put this \n, and that's why we had a switching the line here, and the next print out is below this, and these 3 are the f strings. So we have 3 and 7. So this is how to use the print. Okay, then so we had this CSV file under this name, and the length means we want to count how many rows we have in our data frame. So that's what it does. So that's what the first print indicate, and also we also want to check what are the columns that we have in our data frame. So that goes like our name of the data frame, the CSV file dot columns, and we have a lot of columns. So this indicates that we wish to print out only the first 10 columns. And the next one, okay, I'm gonna separate this into two different cells so that I can show you one by one. So and okay, I'm gonna make another line here. So if we hit the this run execution, we can check that we have 50,000 rows of our data frame, and if you only show what are the first 10 columns, so if let's for now, if we don't have the bracket after this, then we can check are the name of the columns is just too large. So that's why from here we want to have the first 10 columns, and that's what it means. We want to show the first 10 columns, and that goes like bracket, the angular bracket, and colon, and 10. That means from the beginning up to 10th column. So that's how we can only get the 10th column. And we know that we have the country column. So from our data set, so which is here, let's say we only want to get this country. So in that case, we can do this country. So data frame name dot country, then we will have the country names. So all the rest column are gone, right? So we can only see the columns. This column can also be called as this. So bracket, and then the name of the column, and then bracket. And if you can call it in this way or this way. So they are identical. So either way works. And we know that we have a lot of the country name, and that's because even in the same country name, we've been recorded over the years, right? So if you want to print only the unique countries, which is removing the redundancy, then you can do this. Of course, it's too large. So put the bracket and the semicolon 10. That means we want to print out the first 10. By the way, here we have Afghanistan, Africa, and so on. So if you want to just have Afghanistan, which is the first one, then you can put this like a 0. Python started from the 0. So if you put 0, then that means the very first one, which is Afghanistan. And the second one is Africa, and so on. And this indicate from the 0 to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So because it starts from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So 10, we have 10 country names. So that's what it does. So the country, it's long, but we just want to print out the first 10 countries. And here, first, we don't want to use the entire columns because we are not interested of the everything. We only want to have country name, their years, their population, CO2 emission, CO2 per capita, energy consumption per capita, and primary energy consumption. And the reason why we have a primary energy consumption is because we know that the more energy we use, the more likely to emit the CO2. So that's why we have the name of the columns here. And to screen the name of the column, we have to put the two different brackets. And the first bracket, and then the second bracket, we put a list of our country name. And this was our original data frame, and we saved under the new data frame name, which is our new data frame. So once we do that, now we have another data frame that only has these columns. And here we have about 200 different countries. Let me actually count how many countries we have. So So we have 278. I think that's because we also include the continent names. So some of the countries are the grouped, and that's also under the country name. So that's why we have a 200. But yeah, we have a lot of countries, so we don't want to check every countries. So United States, China, India, Russia, Japan, South Korea, Iran, and Canada, they are first the 8 most CO2 emitting country, and also we include France in the end. So we want to investigate on this 9 country, and this line basically screened by the country name, and only if their country name are belong to this list, it will be true. So it will be screened out and it will be saved under this name. So basically it's on the same name, which means we are overriding to the same name. So let's run it. And if we check the first 10 lines of our new data frame, then it goes like this, because countries are located placed in the alphabetic order. So it starts with Canada. The head is to show the first 10 lines. So if you want only see the 5 lines, then we can do this. And also we can also check the last 10 lines, which is tail, then it goes like this. And the reason why we are not the reason why the index number is not starting from the 0 or the 1 is because we just screened it out. So we had Afghanistan and all the other countries that start with A and B. So that's why the previous index, they are gone. So that's why we have the original index, which are not 0. So that's why we have different indexes, but it's okay. It's okay for now. Another thing that I wish to briefly introduce you is that let's see if we have a data frame like this. Let's say this is data frame name. So the bracket typically tell a row or the column. So it typically goes like this: the number of row or the index that are located here, and this is column. So this is column, and this is row. And the row typically called by the integer or the index, whereas the columns are more curated by the name or the string. So that's the difference. And also if we do this, some condition statement, some conditional statement, then that will return out of this data frame. It will give us a subset of the data frame that satisfy this condition. That condition will return either false or true. If it's true, then it will be carried on. First, it will be screened out. So the reason why I just explained that one, so we had a very wrong our new data frame is our data new frame names, and then within the bracket I just include the condition. So within the data frame, let's check the year, and if the year is 2021, which is the most recent year that we have the record, then so we want to print out only the year whose year is 2021. So if we run this command, then we will have a subset of this data frame whose year is 2021. We can also do this 2000, and also we can screen by the country name. Actually, we can also say that the South Korea. So we have South Korea, and if you want to use more than one condition, then you can do this as well. So first condition is name of country is Korea, and the second condition is year is larger than maybe 2010. So South Korea after 2011 to 2021. So because it's larger than 2010, so it doesn't include 2010. But if you want to include 2010, then you can do this. So now we have 2010. Or you can also specifically say if there's two equal symbol. So if you want to print out 2021 South Korea, then you can get this. What if we gave a wrong condition where we don't have such information? For example, we didn't include any North Korea is screened out in the previous step. So in this case, if you run it, then it will give us a empty data frame, and that means this is not wrong, but we don't have such information under this data frame name. So that's why we don't have any existing row. So that's how we have this. So from now on, we are gonna visualize a different plot. Okay. So there are a variety of different types of the plots, and the first plot that I wish to show you is line plot. Line plot goes like this. So we have y-axis, a-axis, and this is line. Maybe some trend over the time or the years. And this particular example, we want to see the population growth in South Korea. So y-axis should be the year, and then the y-axis should be x-axis should be the year, and the y-axis should be the population of South Korea. So if I may go back to the script. So let's see. First, we are screening out by the country. As I told you, country can be called in this way or in this way. Either way works. So please use as you want. So South Korea, and then this time we save it under the df_Korea, and this df_Korea, which is screen data frame, we are gonna do this. So South Korea df_South Korea dot plot, and every after comma we can actually switch the line. In that way we can probably show you how it works in a better way. So first input is kind, and for the kind we are giving the line, because this is called a line plot, and the x-axis so among the column names that we have, because x-axis should not be it should not be random. So x-axis should be some name of the column that we have in the data frame. So we have year, so we are going to use the year, and the y-axis is population, and the title goes here. So this is more for decoration. So title, and the y level is here. So if you have some unit, then you can say what the unit for this. Of course, this population. This number of people. And the grid is the background grid to help us to analysis of the figure, and this is totally optional, so you don't necessarily have to have it. So okay, this will be the Korea. South Korean population recently getting flat or decreasing, so I'm gonna make this. And the label is to include the legend. So okay, if we have a label, then we will have this, and it will tell this color, and the name will be South Korean population. South Korean population. I will just say SP or Korean population, KP anyway. Run it, and this is what you get. So this blue line indicates the South Korean population, and we also have that information in the title. So this redundant. Yeah, if you want, you can actually remove the label. It's up to you. And then we also have the grid. It's also optional. And then the y-axis is too large, so it's a 10 to the 7, which is 10 million. So 10 million, 20 million, and 50 million, and over the years. So from the 1850 to 2021, and as I said, South Korean population is flat and about to decreasing due to the low birth rate, which is bad. In the next line, we want to make this line plot for the other countries. So I'm gonna skip this part. So basically what it does, it has looping statement to run this script over the country. So every country will have different colors, and that different color will be shown in the legend. So South Korea, no, Canada actually has the smallest population, and South Korea, which is shown in the gray line, is second smallest, and then the France comes next, and of course China and India, they are really high. So this is line plot, and another line plot that I wish to show you is in South Korea. Okay, this is the same. So now, instead of the population, we wish to have a CO2 emission, and the CO2 emission, the column name is CO2 2. So I put the CO2 2, and here we have the name of the title of the figure, and here Y level, and here I also put the unit. Unit for the CO2 emission is megaton. So that goes by like a capital M and lower T. So if I run it, and we can see, of course, we didn't have any record before 1900, so that's why we only have the lines only if we have record. Otherwise, it will be just empty line. So that's how we work. So we somehow didn't have any record in here, and of course, industry in South Korea evolved after 1960. So now we have a very dramatic CO2 emission growth after this year, and then this is where we are. And then the reason why we had a plummet after 2019 is because of the COVID. So we had a less emission than previous year, but that doesn't mean we are doing much more significant renewable energy than the previous years. It just due to the COVID, and most of the country had a pretty much similar trend. We can also visualize it over the different country. Okay. And the next plot that I wish to show you is called bar chart. So this is line chart. Okay. So what is bar chart? Bar chart that goes like this. So y-axis, x-axis, and this. So I want to have the CO2 emission per capita person. And then the x-axis should be the country name. So different country may have a different CO2 emission per capita. So we checked that the China had a most total emission from the country, but that doesn't mean CO2 capita is also highest. So we want to check it from the bar chart, because bar chart is more, it's better for the comparison of such information. So and then because for the bar chart we can only check the only specific year, so we want to check the recent year, which is 2021, the most recent year. So let me change the row or the line. So here we screen our data frame by year, and whose year is 2021. So we want to check only 2021, and from that data frame we get the plot. The kind is bar chart. So now bar x-axis is country. I missed R. So in the y-axis CO2 per capita, and the title. So we have, oh, this is in 2021, and the y-axis, y level, we have unit as well, and the unit is ton per person. So how many tons each person emit in a specific country, and grid on, it's optional. And the legend first. We don't need a legend. You know what, you can see what I meant here. So we don't need another legend here because it's pretty much straightforward, right? So this is 2021. What if we want to check the 2010? So change to the 2010 and change to 2010 and run it, and we can get right away. And we can actually have as many plots as we want over and over again. So that's the beauty of the Python. So once you create your workflow or a script, which is really not a script, actually just 2 lines, 1 and 2, right? We did some of the pre-processing of the screening the columns and country, but other than that, just 2 lines, and you can run it repeatedly. And if you are more comfortable with the Python, then you can even make this iteration in an automated way. So you will get to know by the end of this semester, 2019. So we have another plot and so on. And then the next one is pie plot. So from the CO2 emission, I wish to check the proportion of the CO2 contribution in a total emission. So in 2021, from the 9 country, I want to make the pie chart like this. And of course, we only have a 9 country, and this 9 country, the sum of this 9 country is not going to be the same as the entire CO2 emission into the air in the last year. But let's assume that only these 9 countries are contributing 100%. And if so, yeah, we can have something like this. So South Korea, France, or Canada, and so on. So that's what we wish to plot here. So screening 2021. Actually, we already screened the previous cells, so it's redundant, right? So we don't need it. And DF is already what the DF that we want to have. But anyway, yeah, I just have another screening so that just be sure. And what else? df.plot, the kind is pi, so it's pie chart. And then x-axis indicate how do we want to categorize this portion. And we want to categorize this portion by the country. So we have CO2 emission, and we want to categorize by the country. And then the y, the variable that we want to get the portion is the CO2. And this is the additional input for the pie chart. So if we want to include a proportion of the South Korea, let's say if it's a 20.1%, it might differ. So yeah, and so on. So we want to include that number in that pie chart. So that's why we have this. So it's okay for now. And this shows us what the format is, and the reason why we have a decimal point and 1 that indicate that we want to check the or we just want to have like a 1 significant value after this decimal point. So instead of 20.123%, we will just have 20.1, and that's what it meant. So we are going to include that percentage and the labor. So we want to have the name of the country in each pie plot. So that's why we need a labor, and the labor goes by the country name, and the legend it's not necessary, and the y label is necessary. So I just gave the empty string, and the title is 2021. And if you hit the enter, then this is what we got. Its countries, their proportion, and so on. And of course, if you want to change the year, you can change the year and also change the year in the title. And in 2005, United States was the most CO2 emitting country among this 9 countries. and out of this 9 countries, South Korea was contributing 2.8%. So I will just move it back to 2021. Okay, you can play with it. And the last plot that I wish to share is scatter plot, which is my favorite plot. I can show you the I can briefly show you why. So scatter plot looks like the line plot. The only difference is that they don't connect all the lines. So we will have data that goes like this. And this is really powerful because by having the scatter plot, we can briefly see the relationship between the x variable and the y variable. For example, x variable can be the energy consumption, and the y variable can be CO2 emission. So if you want to do some analysis based on the if you want to do the analysis on the relationship between the energy consumption and the CO2 emission, then we can have this scatter plot, and of course they might have a very strong very strong correlation between these two. The more energy, the more CO2 emission, right? So this is what we wish to have here. And for this one, we didn't screen anything. We just included every country, every year, and the kind is scatter plot, and the x-axis energy consumption, primary energy consumption, and the y-axis is CO2, and the legend is true. Okay, this may not be necessary. I think I can skip it, but for now, I will just skip it. Okay, I think I don't need it. Okay. And the y label and the x label. So x label energy, the unit is terawatt hour, and the y-axis megaton, and then the title so the title is y-axis versus x-axis. So the relationship between the CO2 emission and then energy consumption, and this is how it look like. If I may do a brief analysis on this result, yeah, globally, the more energy, the more CO2 for sure. But I kind of see the two different lines, two different trends here. I think we can possibly categorize with one line here and the another line here. And so here, one line here and the other line here. One line goes like this, the other line goes like this. Why is that so? Why do we have a different slopes? And different, what does different slope means? That means with a given amount of energy, depending on their energy system or the portfolio of energy, their primary energy resources, they might have a different amount of CO2 emission, right? So I didn't categorize any, I didn't label any country name here or there, but one thing for sure is there are two groups of country where group A and B, and I think the group B had less CO2 emission within the given CO2 emission. Whereas the group A had a more CO2 emission with the same energy consumption. So that indicates that the group A country, I don't know yet because I didn't label it, but that's what I was about to do. But I will stop here. But the group A, they probably heavily rely on the fossil energy, whereas the B, they probably rely on more or transform to the more renewable energy. So that's why they've been emitting the less CO2 emission than group A. So these are the practice that we can move on, and there's more things. There's much more things. So now from here, this is just for the visualization, but you can do a lot of statistical tests or statistical analysis to prove my assumption. This is my assumption. This may not be, this may or may not be true. So we don't know until we do the analysis. So this is basically our starting point, and these are the assignments. So following this description, please make the formal plot and then copy and paste it in the PDF, and then please submit by next Tuesday. So I will stop here today. And for those who have any question, please let us know and let TAs know. Thank you. Stop sharing. Okay. Thank you. Thank you for listening. Bye.